Hey everybody, in this video I'm going to go through the remaining section of lesson 3.8, and this is going to be about constructing polygons inscribed in a circle. So let's first talk about what that means. So I'm going to first start by drawing a circle. And then let's say I have an equilateral triangle inscribed in a circle, or an inscribed equilateral triangle. What this means is that the shape is within the circle, and the vertices of the polygon are intersecting or touching, they intersect the edges of the circle. Oops. So if we have an equilateral triangle, perhaps one of my vertices, first of all, let's establish the center. It's right here. Precisely. Right about there. One of my vertices perhaps is right there. One is here and one is here. And then these sides form the equilateral triangle. We could also have a square. Perhaps one of the vertices is right here. Oops. Another up top still. And then we have these two vertices. Oh, mine are kind of off. This is more of a rectangle inscribed, but you get the gist. Inscribed means that it is inside the circle. Inscribed inside perfectly, right? So that the vertices are touching. So we're going to start by using a compass and straight edge to construct an inscribed equilateral triangle in circle D. Your final answer should be exactly 3 blue line segments. And I was actually recording earlier and it marked me wrong twice. So be careful when you do these because it can be a little bit finicky. I didn't do anything wrong. It just didn't like necessarily how I started the problem. So when we start this problem, I'm going to begin by using my compass, and kind of intuitive to us, a lot of us might start by centering it on D and extending it to the outside edge of our circle. We're actually going to do the opposite here. We're going to start on the outside edge of our circle and measure to the radius. And I think it is best to start right below point D on our circle. So start on the outside edge of the circle and stretch the compass to be the width of the radius up to point D, and then you will mark the two intersection points. These are technically 120 degrees away from each other. You just mark them on both sides. That's how I like to think of it. Then you're going to move your compass. Your compass is now going to stay the same radius width throughout the entire problem. And I'm going to move my compass to one of the intersection points. I'm going to move it around counterclockwise, and I will strike an intersecting arc about 60 degrees away. And then I will move my compass, always by the center. I will move it to that new intersection point, and I will strike another line about 60 degrees away. And this new line that I just drew, this is the fourth line I drew, that is the third vertice of the triangle. The first two arcs I drew down at the bottom, those are the other two. And then this one that currently my compass is centered at, that's kind of like the jumping point. So we will use the segment tool to construct the sides from each of these intersecting points on the outside of the circle. And this is an equilateral triangle. All right, I'm going to do one more of these. So again, use the compass. If I want to construct an inscribed equilateral triangle, I will set my compass center on the outside edge of my circle and then measure it up to point A, the center, and I will strike 2 lines on both sides. I will move my compass, strike an arc. I will move my compass again, same radius. I'm never adjusting my compass's radius once I measured initially, and then I will strike this top point here, this top arc. So now I can form the segment sides of this equilateral triangle. All right. I am going to do a hexagon next. That. So we're going to construct a regular hexagon inscribed in a circle. And side note, a regular shape, a regular polygon has same side lengths with the same angle measures. So that's what regular means. We don't have different side lengths, different angle measures. They are all same. So this is a very similar process. You essentially are going to do what we did for the triangle, but you're going to repeat it a couple more times. So I will start by using my compass, setting the center of my compass on the outside edge of my circle and the radius to the center. And then I will construct those two intersecting arcs on both sides. And then these are 2 points, right? These are 2 of the vertices of my hexagon. I'm going to move my compass, keeping it the same radius. I will move it, and I will construct the intersection points on both sides this time. So now I have 4 of the intersection points, 4 of the vertices, and then I will move my compass once more. And now this time I only have to draw 1 segment. This will be my 5th vertex. And then keeping the compass the same radius. If you change the compass's radius at any point, you're going to be wrong. So please make sure you're never changing or moving the compass by any point but its center. And then I'll move my compass once more to this top point, and I will construct 1 more intersection with the circle. So now I have 6 intersecting lines, which form the 6 vertices of my hexagon. So I will use the segment tool to draw segments between each of these intersections. So one more time to see it kind of quick. Oh, and this one's really small. So let's use our compass, set our point or our center on the outside edge, stretch it to the radius, draw those 2 intersection lines, those 2 intersecting arcs, move our compass. I'm going to go this way this time. We're going to move our compass to one of those intersection points, and I will draw the intersecting arcs on both sides. I will move our compass same direction, because if I move it back, I already constructed those 2 arcs. So once I've decided to move it to the left, that's the way I'm going. To move it clockwise, that's the way I'm going. So now I will move it to this new intersecting arc, and I will draw another one. And then finally, I will move the compass once more, draw my final intersecting arc. So now I have my 6 vertices that I can draw segments between. All right, last one is the square. And the square is a little bit different. I like the square. The square is nice. Really, what we are going to do here, we're going to begin by drawing the diameter of our circle. So I'm actually just going to use my line tool to construct a line from or through point O, the center, to anywhere on the circle's edge. And then you'll notice that this diameter is formed. So these 2 intersection points, those are the two opposite corners of my square. The other 2 opposite edges should, the 2 diagonals should intersect to form 90 degrees. So if I form a perpendicular line through point O to the line we already have, wherever we intersect the circle, those 2 intersection points will be the other corners. So I'm going to use my compass now, and I'm going to draw or find essentially where I think the perpendicular line through point O would be. And I want to be very careful here, because if I clear up my, or if I cloud up my drawing too much, it can be kind of difficult. So I am going to center my compass at one of these endpoints of the diameter, and then I will set the radius to anything past the center, past O. And then I want to approximate where I think the perpendicular bisector would be through this diameter. And so I think it would be about up here and maybe down here. I am not going to intersect the circle at all when I draw these lines, because if I do, that's going to create a point that Delta's going to want to use. So now I'm going to move my compass over to the other point on my diameter, the opposite point, and I will find where our perpendicular line actually should be. So I will draw my intersecting arcs again, where about I think the perpendicular line will be. And that way now I have these two new intersection points. So I can draw a line through this intersection point and the bottom intersection point. And now you will notice, I also could have done the top intersection point through point O, the top intersection point, or the bottom intersection point through point O, any 2 points on the line. But now I have these two new intersection points with this circle, right? I almost have this new diameter that's formed, and it is perpendicular to the diameter we constructed the first time. And now I can use the segment tool to construct segments between these 4 vertices. So construct your diameter, construct a diameter perpendicular to that one, and then you will be able to draw your segments. So I'm going to do this one more time. So again, I'm going to use my line tool, and I will draw a line through the center, extending to a point on the circle. And now I have this diameter that I can construct a perpendicular bisector through. So I will use my compass tool. I will center it at one of my endpoints. I'm going to do this one this time. So one of my diameter endpoints, and then I will set my compass's radius to past this midpoint, past the center. Now, thinking about where this perpendicular bisector will be, maybe it's going to intersect about here and about here. But again, I want to be very careful. I don't want to use my pencil and intersect the circle at all, because that's playing a dangerous game. If I even, and I'm going to show you what happens, if I use my pencil, it puts a point there. And I don't want that. So I drew my predictions. Now I need to move my compass to the other point to actually figure out where they are. So I'm going to keep the compass the same radius, and I'm going to move by the center over to the other point. And I'm going to find these intersections, and I'm going to have to kind of shimmy it back a little bit. So I'm going to draw my intersections. I'm not going to touch the center of the circle. So this one, it was able to find where they intersect, but I'm going to move the compass by its center back to the first point we were at, and I'm going to extend our first arc just a little bit down more. So maybe when I first used my compass, maybe I should have set the radius something a little bit bigger. So that way, when I move it over to the other side. Either way, now I have lots of possibilities to construct a line through. And I now have 4 points on my circle that are the vertices of the square. So again, it's super important that when you're drawing those estimations for your perpendicular line, that you're not intersecting the circle, because it's going to create a point. And if you have multiple points, it can be tricky. I also think Delta is going to count you wrong if you have multiple points on that circle besides your vertices. All right, let's submit it. Love it. Alrighty, y'all. Please keep practicing these skills. Let me know what questions you have, and I look forward to seeing you in class.